I'm going to demonstrate you different type of control flow you can implement using operators, because all operators in IA, they are all about mappings, and by mappings I mean natural transformations. I'm not going to explain you theoretical foundations behind them, since it actually takes some time to grasp it, and you can just go and read those articles. The link is going to be in the description of this video. Okay, let's go. We have some optional value, and this optional value is unit. Okay, and we want to check, let's say we want to pattern match on this value, because it can be either sum or none, which resembles some object. Let's say that we have example, and we want to okay, no. So what we want to do is to pattern match. If it's none, return a string which is none. If it contains some value, then print unit. So this is gonna be a list of ASCII characters, and we are going to print it. Wait, or both, it's gonna be the same output. Okay, it seems to be working, and let's change it to none, which means that it doesn't contain anything. Okay, it's none, works. To pattern match optional values, the next step is to try to map something, since I promised you that we're going to talk about mappings, right? Let's take this simple operator as an example. So it's called Yoneda identity, which, and you can see, if you see identity, it means that you cannot actually, you don't actually map anything, since it's the identity. That's why this circle is empty. And here, because you don't map anything, it works as a reverse application operator. So we can use this is expression, which is often used to give hints to a compiler with which type of value we are working on. Here we can say that it's optional unit. Okay, so since it's empty circle, I think there are there are actually circles that are not empty. Another example is YO, which stands for Yoneda covariant, and here we can map over contents of optional value, which here again it's unit. All right, so yeah, it does compile. So here it's none, because it's none here, but if there is something, it will show us unit. Yeah. Let's use strings instead of unit. Here we can say is list of ASCII. Yeah, actually we can just create a type alias, so we don't have to type list ASCII all the time. Oh, sorry. Okay. So it's not going to compile, since here we have unit, and here we say that it's string, but it's not actually string. Let's change that. Let's name it that there's something. Okay, something. And here we should change it accordingly. It's string, and this is string. So actually here we don't need it anymore, since we already say that it's string. Okay, now our compiler says that there is something. Okay, let's make it shorter. Okay, what's next? We have an access to string, but we didn't really change anything here. But we actually can. We can replace this string with another one, so that we completely ignore the fact that it even exists. So this is actually what effects are all about. So we were able to replace it. So this dot is working as a constant function, and we actually can use another operator for that, special one, which is pretty similar to this unite the covariant, but instead of O we use U, so that this way we can replace that, and it's going to be the same. Okay. So the next step is we can do some bindings. So for bindings we use this hooks. There can be small hooks, there can be big hooks, but for this one we use the small one, which means that it's classly morphism in source category. Yeah, it's all described in those articles. So if you are really interested, what the hell does it even mean, you can just go and read it. Okay, so we are going to some bindings, and with this binding we are going to check. We can say check if there is any value. So this computation and this step is going to work only if there is some, because if it's none, it's just going to, we're going to finish here. Okay, let's say that we want to replace again this value with another one. We can say, is there something? So as you can see, it works, but if there will be none, then it's not going to work. Yeah, it's still none, because doesn't matter what we map, in which way, if there is none, it's not going to work. So this whole part is not going to work at all. We actually can make this code even shorter. Take a look at this. So string is a list of ASCII, right? And it's also optional, which means that it's wrapped in two effects. This optionality effect, which says that there can be a value and it might be absent, and also there is a list effect, which means that there can be no ASCII characters or can be many of them. So what we can do is that we can map over these two effects and get access to this ASCII character. And for this ASCII character, we can bind it to another effect, which in our case is going to be world, which actually another word, another name for AO. So let's say we have this example. We can map it twice, so that first we check, because it's optional. Then since it's a list, we can specify in which order we want to traverse this list, and then in the end we say it's world output. Oh no. I got it. It's actually, it doesn't know it's a string since it's a literal. It can be not just list of ASCII character. It can be non-empty list or binary tree, whatever. So we should specify this as a string. Well, it didn't print anything, which means it didn't print anything because it's none. And now we are going to replace it with some. It's actually a good demonstration how it works. Yep, it printed the string that is inside of this optionality effect. Yeah.